All right, let's jump right in. Today, we're unpacking a really fascinating piece of research that directly connects the literal paint job on your vehicle to actual crash data. If you've ever wondered why certain cars just seem to get into more scrapes than others, well, we've got the statistics to explain it, and it's a wild ride.
Okay, let's dive into this. Does your car's color actually cause accidents? I mean, it kind of sounds like an urban legend, doesn't it? The idea that some aesthetic choice you made at the dealership is secretly putting you in danger out on the highway. No way, right? But the data provides a definitive, highly scientific look at this exact question, and it gives us a pretty mind-blowing perspective on traffic safety.
Section 1. The Color Crash Connection. Section 2. High Risk, the Invisible Cars.
To really wrap our heads around this data, we're actually going to work our way backwards today. We'll start right at the top with the absolute most dangerous vehicles on the road. The danger in this highest risk category, which we'll call Tier 3, is rooted entirely in pure physics and the environment. The specific colors making up this high-risk group: black, deep blue, deep brown, and deep green. You see these sleek shades everywhere, right? But according to the crash data, these dark, rich colors share a common trait that makes them statistically way more likely to be involved in a wreck. So what's the big issue? Nighttime invisibility. Honestly, this is the terrifying reality of driving a dark-colored vehicle. When the sun goes down, these cars essentially just disappear. The lack of ambient light means that black, deep blue, or dark green paint just absorbs whatever little light is left out there, completely stripping away the vehicle's visual footprint.
And man, it gets so much worse when the weather turns. Dark colors are incredibly difficult for other drivers to spot in rain or snow. Because they're dark, they naturally just blend right into wet, dark gray road surfaces. They also hide perfectly in the environmental shadows cast by trees, buildings, or overpasses. So just to be super clear here, it's not that a black car is inherently more dangerous in how it drives. It's simply that other drivers have a much harder time actually seeing it when conditions are anything less than perfectly sunny.
Section 3. Medium Risk, the Human Factor.
Now, what's really interesting about this slide is that as we pivot into Tier 2, our medium risk group, the entire nature of the danger shifts. We're no longer talking about physics and lighting, we're talking about the human factor. For decades, there's been this persistent myth that the color red is naturally dangerous or maybe even cursed. But the reality? Red vehicles are statistically favored by sports car owners and drivers who just tend to have more aggressive driving habits. So yeah, the accident statistics for red cars are higher, but it's absolutely not because the color itself is causing the crash. It's driven entirely by the specific demographics of the people buying them. Simply put, it's the driver, not the paint.
Also sitting right here in this medium risk category is gray. Now, gray vehicles have fairly average visibility, generally speaking, but their specific danger comes from their tendency to perfectly camouflage into concrete city environments. Think about it. A gray car, driving on a gray road, surrounded by gray concrete buildings, it becomes remarkably easy for the human eye to just gloss right over it, which, you guessed it, leads to accidents.
Section 4. Low Risk, Maximum Visibility.
All right, let's shift away from the danger zone. Here we find the safest choices according to the research: white, silver, yellow, and orange. The one defining characteristic of this entire group is maximum visibility. The common thread is that all of these colors make it significantly easier for everyone else on the road to spot you. Now, the data does note that yellow and orange are pretty rare to actually see in the wild, but they are incredibly safe. That said, white and silver remain the most consistently safe, stable, and widely available choices you can possibly make to lower your risk.
So why do these colors dominate the safety charts? It comes down to what we call the high contrast advantage. These specific light, bright colors naturally create a massive visual contrast against the typical driving environment. Whether it's daytime, the dead of night, a pouring rainstorm, or a total blizzard, these colors stand out sharply against the asphalt and the surrounding shadows. Let's detail exactly why this matters so much. Because they are so highly visible in all weather and have such a strong contrast, these colors trigger extremely fast human eye recognition. Our brains are literally hardwired to notice high-contrast objects quickly. By the time a driver's brain registers a dark car lurking in the shadows, it might already be too late. But a white or silver car? The eye spots it instantly, giving the brain those precious extra milliseconds to react. And that significantly reduces the chances of a collision.
Section 5. The Real Drivers of Risk.
And this brilliantly illustrates everything we've synthesized today, showing the complete spectrum from safest to highest risk in one clear view. We start with the highest safety of our bright whites and silvers, step down to the medium behavioral risk of reds and grays, and finally hit the highest risk with those low-visibility dark colors. Laying it all out like this reveals a super clear overarching trend. The darker and less contrasting the car is, the higher the overall risk trend becomes.
All right, we have reached the ultimate takeaway of this entire visual analysis. If you remember literally only one thing from all the data we've broken down today, it needs to be this final concept.
Let me read this exactly as it comes from the research conclusion. The core factor affecting accident rates isn't the color itself, but how easily it is seen and the differences in driver demographics. Boom! It is such a profound realization. The true culprits of color-related crashes are sheer visibility, how fast human eyes can detect you, and who happens to be sitting behind the wheel.
So, it leaves us with this. Next time you buy a car, will you choose pure style or will you choose to be seen? I know, it's so tempting to go for that sleek black paint job, but knowing the actual physics of safety and the limits of the human eye, maybe that bright silver or stark white is the smarter choice. Thanks for joining me to unpack all this data today. Stay safe out there, stay visible, and I'll catch you on the next explainer.